Hello, good afternoon. My name is Upasana Talukdar and my roll number is 34900322006 and I am from Electronics and Communication Engineering Department, and this is my subject Digital Communication, and I am from third year, and today is my topic is pulse code modulation. So let us start with introduction of pulse code modulation. When a digital signal undergoes pulse code modulation, it converts the analog information into a binary sequence 1 and 0. Through the demodulation process, we can obtain the original analog signal. Pulse code modulation techniques are used to produce a series of numbers or digits in a binary form. Hence, the process is called digital modulation. The amplitude at the particular time of the signal sample is indicated by the binary codes. In PCM process, a sequence of coded pulses indicates the message signal. This message signal represents amplitude and time. Pulse code modulation basically are two types. Number one, DPCM or differential pulse code modulation. Number two, ADPCM or adaptive differential pulse code modulation. Differential pulse code modulation is a signal encoding process which adds functionalities based on the prediction of the sample of the signal. Adaptive differential pulse code modulation is a technique in which the size of the quantization step is varied to allow the further reduction of the required data bandwidth to given signal to noise ratio. The pulse code modulation process is done through the following steps. Number one, sampling. Number two, quantization. Number three, coding. Then we come into block diagram of pulse code modulation. In pulse code modulation block diagram, first a analog message signal is given, then it will be convert in a LPF, and then it will be convert in a sampler, and then it will be convert in a quantization, then the quantization convert in a encoder, and from encoder to regenerative repeater a PCM output will given to channel, and then between regenerative repeater a channel will create, and then the channel output um, is generate, and generate repeater will convert in a regeneration circuit, and regeneration circuit will convert in a decoder, and then decoder convert in a reconstruction filter, and then reconstruction filter will convert in a destination. Then we start with quantization. The PCM signal is generated by carrying out following basic operation. Number one, band limiting using LPF. Number two, sampling. Number three, quantizing. Number four, encoding. Two fundamental processes are involved in the generation of PCM signal. Number one, sampling, and number two, quantization. Sampling is time discretization, and quantization is amplitude discretization. In PCM conversion of analog signal to digital signal is done in two steps. Number one, sampling. Number two, quantization. Then we come into transmission bandwidth in pulse code modulation. The transmission of a PCM system is associated with a number of bits per sample. If the number of bits per sample increases, the bandwidth also increases. In order to have a good approximation, a large number of labels must be used, but that will lead to a larger bandwidth requirement. Let us consider each quantizer label is represented by n binary digits, then the label represented by n binary digits given as q is equal to 2n. Q is the digital label of the quantizer. Every sample is changed into n bits, thus a number of bits per sample is n. As we have already discussed, the number of samples per second is fs, hence the number of bits per second, which is also termed signaling rate, is given as r is equal to nfs. As transmission bandwidth is half the signaling rate, hence bw greater equal to half r. As we have already discussed, r is equal to nfs, therefore bw greater equal to half nfs. But we know fs greater equal to 2 fm, thus the bandwidth of the PCM system is given as bw greater equal to n fm. Then we come into SQNR of pulse code modulation. Signal to quantization noise ratio is an important parameter in pulse code modulation system which determines the quality of the digital signal. It is defined as the ratio of the power of the input signal to the power of the quantization noise. It is expressed in decibels, and higher the value of SQNR, better will be the quality of the digital signal. Then we come into factors of affecting SQNR in PCM system. Number one, number of quantization levels. SQNR is directly proportional to the number of quantization levels used in PCM system. Higher the number of quantization level, higher will be the SQNR and better will be the quality of the digital signal. Number two, nature carrier wave. The SQNR is independent of the nature of the carrier wave used in PCM system. Number three, sampling rate. The SQNR is independent of the sampling rate used in PCM system. However, the higher sampling rate, better will be the quality of the digital signal. Thank you.